All right, hello everyone. Welcome to my channel. This channel is for the purposes of education, and we generally look at theories of everything in depth. And today is the 335th video that we've done on Dewey B. Larson and his reciprocal system of theory. The reciprocal system of theory was something that Larson first had an inkling of back in about 1930. Took about 25-30 years to kind of work out the kinks of his ideas and to put it into very concise form of his two fundamental postulates, which are only, basically like two sentences. And then he took those two postulates and through a period of deduction came up with a theoretical universe, how the universe would work if his postulates were true. And then from there, he wrote books based on those that theoretical universe that kind of compared his universe with the theoretical, with the observed and articulated universe of legacy science. In most cases, his theories really agree very closely with the legacy scientists, the Newtonian worldview. But like Einstein's theory of relativity, in those areas on the margins of the very fast, the very small, and the very large, Larson's theories diverged from the Newtonian worldview. Those are kind of like what would be called the relativistic areas, same areas that Einstein was trying to correct. In many cases, the corrections that Larson made were mathematically the same as kind of what Einstein made, but conceptually very, very different. Einstein many times did not have the concepts, the proper concepts behind the things that he was doing, and a lot of times he was just borrowing math from somebody else, and was using a lot of fudge factors and things that weren't not just Einstein, but like kind of the Einsteinian revolution. But Larson has the concepts. He can tell you why this doesn't work, why we have this math the way that we have it. In some cases, in many cases, for the Einsteinians, the math was just the math, and it didn't mean anything. For example, for Heisenberg, thought that there was nothing behind the math. It's just math. It has no meaning conceptually, and so that's what Larson is kind of. I think that's one of the far-reaching consequences of his theory. Now, the basic idea in Larson's system is that we live in a universe that is made entirely out of motion. Not matter, not energy, not force, but in fact, all three of those things are just specific kinds of motion. And for Larson, motion was the relationship between space and time, which creates a reciprocal relationship between space and time. Motion is basically a fraction with space or time as the numerator, time or space as the denominator. And space or time are the same, except that they are reciprocals of one another. And so they have the same general qualities, one of which is that they are both three-dimensional. Whatever quality one has, the other also has. And so Larson refers to this as coordinate space and coordinate time. 3 dimensions of space, x, y, z coordinates. 3 dimensions of time. You might think of that as ijy coordinates or ijk coordinates. And space and time also have their clock aspects, clock space and clock time. This is what is referred to as a scalar motion, a motion that has a magnitude, but it has no specific direction. The clock is always getting later and later and later and later, but in no specific direction. And so too, the space is always getting farther and farther and farther apart, but in no specific direction. And you can envision this using a balloon with dots on it. You blow up the balloon, all of the dots are moving away from each other. And that is a scalar motion. They're not moving in any particular direction, not until you identify a reference point. When you identify one of those dots as being stationary, then you can see the motion away from that particular, you can see the direction of the motion away from that particular dot. But that is actually a property of the reference system, not a property of the motion itself. The motion itself has no direction. It doesn't have a direction until you assign the reference point. And then the last thing in Larson's first postulate is that space and time only come in discrete units. There is a minimum unit of space and a minimum unit of time. Below that, you have no space and you have no time. And if you have exactly 1 unit of space in 1 unit of time, you have the speed of light. The speed of light is what Larson calls unit speed. 1/1 equals 1. And that basically is the crux of the reciprocal system. 1 is the center. So half of the universe is moving faster than 1, or faster than the speed of light, and half of the universe is moving slower than the speed of light. That's the key. One of the key differences between Larson's system and the legacy system. The legacy system, its background or its 0 point is actually 0, meaning that +1, +2, +3, +4, +5 on one side, and -1, -2, -3, -4, -5 on the other side. But in Larson's system, 1 is at the center. You could think of that, if you want to call it the 0 point, you would think of 1 to the 0. 1 to the 0, or anything to the 0, is 1. So you would think of it as to the 0 power. Instead of the 0 point, you might want to call it the 0 power. And on one side of the balance, you would have 2, 3, 4, and 5. But on the other side of the balance, you would have 1/2, 1/3, 1/4, and 1/5. So they multiply to 1 as opposed to adding to 0. And so if you have unit speed as your 0 power or your 0 point, then half of the universe is actually moving at speeds faster than the speed of light. Larson calls that the cosmic sector. And then half is moving slower than the speed of light. Larson calls that the material sector. The material sector is really the only sector that legacy science knows about. Hence, Einstein's dictum that the speed of light is the maximum speed of the universe. In Larson's universe, the speed of light is the midpoint, meaning that Einstein is missing half of the universe in his formulations. And but it's not necessarily fatal, because whatever is going on in the material sector is exactly the same as what's going on in the cosmic sector, as they are reciprocals of one another. The only thing that you have to do is invert the roles of space and time as you cross that unit speed boundary. So in the material sector, you have coordinate space, 3 dimensions of space, and you have clock time. The clock is always getting later and later and later. But in the cosmic sector, you have coordinate time, 3 dimensions of time, and you have a clock space. The space is always getting farther and farther and farther apart, a la a expanding balloon with dots on it. Also measured and observed by the Hubble telescope, that determined that all of the distant galaxies are moving away from each other. So this scalar motion is fundamental to Larson's system, whereas in the legacy science, they recognize the existence of scalar motion, but they have never really investigated the properties of scalar motion and consider it just a sideshow. For Larson, it's at the center. Now, today we are on, I believe, the 4th episode of going over Larson's paper that is called The Mechanism of the Universe. And in this paper, he's talking mainly about cosmology, looking at the macro universe, like the astronomical. He went over the major models of cosmology, the Big Bang, the oscillating theory of the universe, and the steady state theory of the universe. These are 3 different models of how the universe formed. And he more or less rejected all 3, or at least parts of all 3. And eventually he's going to be kind of proposing how he sees the mechanism of the universe with his idea of the universe made out of 3 dimensions of scalar motion in discrete units. And so we're going to start here with Larson's paper, and we'll see where we go. Here, in these immediate consequences of the concept of a universe of motion, we have an explanation of the recession of the galaxies that comes directly out of basic theory and requires no ad hoc assumptions. The universe is moving outward at the speed of light in all directions. That is the 0 point, or the 0 power of this universe. So that explains the recession of the distant galaxies right out of the chute. But it should now be evident why I raised the question with respect to the current belief that the answer to the galactic recession is the answer to the whole cosmological problem. The explanation of the recession at which we have arrived does not solve the problem. It merely rules out the ad hoc assumptions that have been made and thereby deepens the mystery. The ultimate fate of the receding galaxies is still a wide open question, and the origin of the galaxies is more of a problem than before. Continuous creation is inconsistent with the basic elements of the new theory, and the Big Bang concept is eliminated from consideration, as the recession has been identified as due to a different cause. But the galaxies that formerly occupied the regions just beyond the gravitational limits have moved away, and yet there is no additional vacant space. Where did the present occupants of these regions come from? We can approach this question most conveniently in a sort of roundabout way. Another line of deductions from the basic postulates, an extension of the deductive chain from which we arrived at the nature of the atomic structure, discloses that this atom is subject to an age limit. Now, this comes from his string of deductions from the fundamental postulates from which he created his theoretical universe. Now, if you go way back in the archives and some of the first episodes of these 335 episodes I've done about Larson's theory, I did about 15 episodes on Larson's outline of the deductive development of the reciprocal system. So he has 165 or so steps that he takes to go from his fundamental postulates to his theoretical universe. And within those steps, he covers where the atom comes from. The atom is a combination of different rotational motions. Everything is made out of motion, and an atom is a combination of a few different rotational motions. And it is also subject to an age limit, meaning that as it gets older and older, as time goes by, it builds itself up more and more to the point where eventually it becomes unstable. And so as it gets older and older and older, the chances of it becoming unstable and therefore radioactive become higher and higher and higher. So he calls that the age limit of matter. And that the age limit of matter is what eventually causes stars and galaxies to explode, or maybe implode as they become radioactive. When an atom of matter arrives at the limiting age, its rotational motion reverts to the translational status, which would be radiation or light. So it goes from matter to energy. That is, the atomic mass is converted to energy. A further line of deductions leads to the conclusion that most of the oldest matter accumulates in the interiors of the largest galaxies. The attainment of the age limit on a massive scale in one of these giant galaxies results in a tremendous explosion, which accelerates portions of the remaining mass of the galaxies to a speed in excess of the speed of light. The question then becomes, what happens to this fast-moving matter? For an answer to this question, we need to return to the fact previously deduced that space and time are the two reciprocal aspects of motion and nothing else. This means that the reciprocal relation is a general relation that is effective throughout the universe. An immediate consequence is that for every physical entity or phenomenon, there necessarily exists another entity or phenomenon that is similar in all respects except that space and time are interchanged. The inversion may be only partial, applying to only one of the motions involved, the translational motion, for example, or it may apply to all of these motions. All of the familiar entities of our material universe are therefore duplicated in the inverse manner, which leads to the conclusion that what we have been regarding as the physical universe is actually only one half of the physical universe as a whole. There also exists an exact duplicate, the cosmic sector, differing only in that whenever space is involved in any of the phenomena of our material sector, the inverse or cosmic sector, as we will call it, substitutes time. Where we have time, it has space, the cosmic sector. Where we have, in the material sector, where we have time, the cosmic sector has space, and vice versa. Where we have space, the cosmic sector has time. The next question that naturally arises is, where is this cosmic sector of the universe? Here, we need to look at the speed magnitudes. As already brought out, the natural reference system is moving at unit speed, which we can easily identify as the speed of light. In our material sector, the prevailing speeds are less than unity, and the result is motion in space. Now, I'm admittedly a little bit dense, and sometimes it takes me a while to get things. But Larson does have a tendency to sometimes gloss over things by using terms like "of course" and no doubt and easily and obvious when he makes a kind of a jump. And a lot of times when he does that, it's not obvious to me and it's not of course to me. It's like, I wish you would explain that a little more. And so here he says, here we need to look, where is this cosmic sector? Here we need to look at it at the speed magnitudes. As already brought out, the material reference system is moving at unit speed. And then he says, which we can easily identify as the speed of light. Now, to me, that isn't obvious, and it's not an easy identification. I really wish that Larson would go slowly over that point to kind of try to explain to me why unit speed is necessarily the speed of light. Now that I've studied the reciprocal system for many years, I think I can kind of figure it out. And knowing that Einstein has the dictum that the speed of light is the maximum speed of the universe, I can kind of think that, okay, well, that makes sense that that Einstein is saying that the speed of light is the speed limit, and that that then easily explains why he doesn't know anything about the cosmic sector, and that there's this entire half of the universe that he's missing out on. I can kind of piece it together once I have a lot of other background information. And it makes sense to me that the speed of light, unit speed, is unit speed. But I just feel a little bit off-put when he says that we can easily identify this as the speed of light. Maybe if I were a adroit theoretician, or if I was a PhD level scientist or something like that. But just as a layperson, that isn't obvious to me. And so I feel a bit uneasy about accepting it. I'm okay with accepting it because I believe that you need to do that with Larson's theory. You have to accept it as is and then debunk it later. You can't, because if you just are skeptical about everything he says, you won't even get past page 1, you know, because he's going to say a lot of things that fly in the face of things that you currently already believe, if you're kind of a legacy scientist. And so I do believe that you have to kind of like accept what Larson says, and then you can marinate it in your mind and see if it adds up, as opposed to just rejecting it out of hand. And so I will accept that what he's saying is that unit speed can be easily identified as the speed of light. But I still feel a little bit, skeptical because mainly just the way that he says it. We can easily identify this. Well, if it's so easy, why isn't it obvious to me? So, just my 2 cents there. In our material sector, the prevailing speeds are less than unity, and the result is motion in space. In the cosmic sector, where space and time are interchanged, the speed is greater than unity, and the result is motion in time, a change of location in 3-dimensional time that is analogous to the changes of location in 3-dimensional space that result from motion at speeds less than unity. Thus, each of the structures of the cosmic sector, the cosmic stars, cosmic galaxies, etc., is separated from us by a certain amount of time, just as there are spatial separations between our location and the various structures of the material sector. We receive the same kinds of information from the cosmic sector that reach us from the distant regions of the material sector. 1, radiation, and 2, individual particles of matter. But gravitation in the material sector is a motion in space, and it produces aggregates in which the constituent atoms are contiguous in space but widely dispersed in time. The radiation received from such an aggregate is therefore highly concentrated in space, and since we are approximately at rest in space relative to the emitting aggregate, we can recognize the radiation as coming from a discrete object. However, gravitation in the cosmic sector is a motion in time, and it produces aggregates in which the constituent atoms are contiguous in time but widely dispersed in space. The radiation from these aggregates reaches us from the widely dispersed spatial locations, and instead of being concentrated in the manner of radiation from a material star or galaxy, it is spatially isotropic. This is the background radiation that has been interpreted as evidence in favor of the Big Bang theory. We likewise encounter cosmic stars and galaxies from time to time, but because of the way in which their constituents are dispersed in space, we encounter them as occasional single cosmic atoms rather than aggregates. So when things come over from the cosmic sector, we see them as widely dispersed, and we see them as individual atoms, not as aggregates. And so that explains what we call the 3-degree cosmic background radiation. I'm glad he doesn't say that that's obvious because it's far from obvious, and it is, you have to think abstractly about that before it makes sense. But it does make sense to me at this point. So anyway, I'm going to stop it off here before I get up on my soapbox again. And we will take over at this point here in the next episode. Thank you for tuning in, and have a beautiful day.